In the one sample t-test, we use it when we're comparing still one sample versus a population where mu is given and sigma is unknown. So this is the main difference, and this is the situation you look for. So in step 1 of the z-test, we parse the problem. It is no change. These and this is no change. In step 2, where we're describing the comparison distribution, we have some changes, but they're not, and one of them is probably the biggest change. The other ones are very minor. So first off, the shape in the z-test is the z distribution, which is that normal bell-shaped curve. The shape I don't know if I should write that all out. The shape here is the t distribution. And the t distribution is a little bit different in the sense that it looks very much like the z distribution when n is big. I forgot I had this problem set up for us. Let's move it over a little, if I can. There we go. So when n is big, when we have a lot of people in our sample, the t distribution looks very much like a normal distribution. So n greater than 30, it looks like that. But when n gets lower than 30, it looks more like this. So the d distribution has a little bit different shape, and so the spread or the cutoff point is going to be more stringent. But it doesn't matter, you can just look it up. More extreme. So the shape is different, but you're still going to be basically looking it up, so it's not that big a deal. And the center in these two tests is the same. Mu is given, and mu is given. No change. The spread in the z-test is sigma, the standard deviation for the distribution of means, which we calculate by taking the square root of the variance divided by n. That's what you've been doing in the last situation. The shape in the t distribution, or the spread, excuse me, the spread is no longer sigma divided by m. I mean, sigma for the distribution of means because we don't know it. Instead, it is s, which is the estimated standard deviation for the distribution of means, which is calculated by taking the square root of something that we're going to call not variance, but estimated variance. And it's going to still be divided by n. Where do we find this variance? In the z-test, we calculate the variance very easily because we just take that sigma that's given way up here, and we square it. In the t-test, we go through a little bit more work to get our e there. We have to get the sum of squares of all of the data that are given. So you're going to be given raw data now. We're going to take the sum of squares and we're going to divide by n minus 1, which we named last class as degrees of freedom. So that's it. That's it. So just right off the bat, is that helpful to you with the question you asked at the start of class, Myra? We'll be going through examples, but is this a helpful simplification? Or anybody, do you have some questions?
It's going to take time for me to understand, so okay.
We'll go through some examples, but this is just a way to kind of give us an overview. And then when we go through some examples, you'll see it. So in the problems for our t-test, you'll see that we're given raw data, like person 1 got this score, person 2 got this score. So we'll work through that. So let's just look at this as your overview. And then maybe we'll look at this again at the end. So these are the differences. And it is good if you maybe write this down. It might help you a little more to remember. Okay, so that is probably the biggest difference. So let's put a star right here because your main calculations are going to be right around this spread. Okay. So in step 3, where we're looking up the cutoff point, there's essentially no change. The only change, we're going to look it up in both cases using the significance level, alpha, and n. And in our t-test, step 3, we're going to look up using alpha and degrees of freedom. So n minus 1. Same thing though, same process. It works the same conceptually. In step 4, calculating the standardized score, we actually have the same formula that we always use. So the basic formula is sample mean minus population mean divided by spread. So that is our standardized score, which is our z-score. And it looks like this, m minus mu divided by, remember our spread is right here, this divided by the standard deviation for the distribution of means. In calculating the standardized score for the t-test, the formula is the same. T, that's the statistic we're going to get now. Instead of Z, we're getting T, is the same thing. Sample mean minus population mean divided by spread. And in this case, it looks like m minus mu divided by, here is our spread this time, the estimated standard deviation for the distribution of means. When I was first learning statistics, I remember these two m's would confuse me. This m for mean, and then this little m here. And so when you see this little m in your subtext, just remember it's not the same thing. That little m means for the distribution of means. Basically, it just means you're dividing the variance by n and taking the square root. So we're to our last step now before we solve a problem. And all of this will, I think, clarify or crystallize for you a little bit. Step 5. We have 2 parts to step 5. We first have to decide whether to reject HO. And in the z-test and the t-test, it is no change. No change in how you make that decision. In the second part, the way we write up the conclusion, the statement, I think I'll just summarize it here. So we write the statement and then the statistic. And we write the statistic like this. We write Z, and then here we write N. Remember, we write that little N, the number in the sample, and then we put the Z-score. And then we put either the p-value or p less than the significance level, or we write not significant. Here, this is very similar. So I would say that there's no change in the statement. But in the statistic, we have just a slight change. In the statistic, we're going to write T instead of Z because that's what we're working with. And then down here in this little text or in the parentheses, we're going to write degrees of freedom, not N anymore. And then we write the T-score for the sample. And then we do the same thing. We either write the probability level or NS if it wasn't significant. So this is a summary of the difference. Are there any questions at this juncture before we go through an example?
Okay.
Okay, then I'm going to announce just for anyone else who might have come in that this timing mistake was on my end. And I think it happened because we started at 11 last semester and I don't have a good excuse and I apologize, and I will be recording our additional examples after class and being there in person next week with a different car, I might add. So that's what we have. This is an overview of the differences, and I want to move into solving the first problem. We're going to solve by hand. So I've put this problem over here, and this is the kind of thing we're looking for.